Now let's go to the third menu. We are going to talk about the process and the instrumentation. We want to take a deep dive in the process flow diagram and in the piping and instrumentation diagram. This is the shape of the PFD and P&ID. Process flow diagram shows the big picture relationship and the main material flow between major equipment in a plant. It's like an arrow going in a town, showing you where to go in a location from this area to this area to this area to this area, so that you can understand all of the fluid going from this equipment to this equipment to this equipment, like a small map showing you the way. So process flow diagram, the process intent. What is a PFD? Process flow diagram is a simplified flow diagram that explains the relationship between major equipment of a plant. It provides a start-to-end understanding of how different types of equipment and the chemicals work together in the process plant, most commonly used in chemical and process engineering to understand fluid flow direction and the connectivity between different equipment through the piping system. All of the connection between the pipe going from this area to this area to this area, from this equipment to this equipment, from this compressor to this pump, are shown in this BFT. There is a 5-step in the development of the BFT. First, the preliminary design. Based on the process simulation you created using Aspen HYSYS, you take this flow sheet and define the major equipment, pumps, compressor, reactor, separator, and establish a process flow. Connect all this equipment with process line and the flow arrow, showing that the fluid is going from this area to this area. The flow is going from this area to this area. Then you added all the operating conditions and the equipment design for each equipment in this drawing. Then review and approval reviewed by process engineer and project stakeholder to be used, as I told you in the previous lecture, in all of the upcoming plant design phases. What is not included in a BFD? Pipe class, the material and the spec of each pipe, its high pressure, low pressure, it's not showing. Piping code info, construction standard, isometric number, detailed fabrication ref, instrumentation tag, detailed identification, only the name of the BCV or the name of the could be issued. Minor bypass, small valve station. Drain and vents are not used in the BFDs. Relief valves or the pressure safety valve location are not mainly used in the BFD. Key point: BFD focus on the major process paths and equipment, leaving all of the detailed instrumentation and the piping to P&IDs. There is a checklist for each PFD you created, the drawing numbers, the page number, latest version, what it's used for, Rev A, Rev B, issued for construction, issued for HACCP, whatever you need. Stream data table with correct units and flow rate, equipment tag correctly formatted and well placed in the PFD, instrument type and logic shown correctly. In the second 2 courses that I made, you can have a look at the case study creation of the PFD in a small plant and in a large natural gas and condensate and LPG production unit. So how to read a PFD? To understand and interpret a BFD, you first identify the major equipment. As you can see here, there is a two-phase separator. Two-phase separator is a compressor, a pump. So now you know what is the major equipment here, and there is an air cooler. Follow the process flow arrows. As you can see here, this arrow is going from this direction, then the liquid is going from this direction, and the gas going from this to this direction. You can see from these arrows where each equipment is going. Understand the interconnection between them. Note all of the operating condition of each of this equipment, which is found in the top of the page. And also you can see the heat and mass balance that is already made in the simulation is attached in the process flow diagram.